Hello, my name is Martin Bloemendaal. In this video we will discuss the current fossil-based heating and cooling system. You may wonder why that is needed in the MOOC on decarbonizing heat supply. Well, this old system is important to understand because in our decarbonization efforts, in most cases we cannot simply replace a fossil-based source by a renewable source. Usually the whole distribution system and installation conditions need to change. To do so efficiently and effectively requires a bit of understanding how the current system works to be able to identify what we need to do differently. Therefore, we will discuss the heat balance of a building and conventional heating strategies, the principle of exergy and why fossil-based systems are not exergetically efficient, and lastly, what the key fundamental changes are needed when we decarbonize the heating and cooling supply of new or old buildings or industrial processes. Here we go. Let's start with the heat balance of a house. It's cold outside, and there is a temperature difference between the desired indoor temperature and outside, which causes heat losses. These heat losses consist of the transmission losses through the roofs, walls and the windows. This is dependent on the temperature difference between outdoor and indoor and the thermal properties of the materials used to build the house. There's also heat loss caused by ventilation. Cold air enters the house when there is no heat recovery. Warm air leaves the house. Additionally, there is heat loss caused by infiltration. That is the unwanted leakage of air through the building envelope. On the positive side of the heat balance, there are also heat gains. The first is the sun. Heat is gained mainly through the windows depending on the amount of solar radiation, the orientation and the size of the windows. There are also internal heat loss, for example. All the electric equipment in the house, lamps, computers, etc. And of course the people in the house. When all the heat gains are not enough to compensate for the heat losses, you need a heating system to provide the required comfortable temperature. And here it becomes interesting, because what we used to do was to install a small radiator or other heating device in every room, so small that these systems need high heating capacities to meet the heating demand. To understand this, the heat transmission equation is introduced to you on the slide. In this example, we simplify the radiator to a two-dimensional surface which exchanges heat with its surroundings, a room in a house. To meet a given heating demand, the heating power that the surface area generates depends on the material of the heating device, which is fixed once you have installed your radiator or heating device, the surface area, which is small, and the temperature difference between our surface and the desired room temperature. The desired room temperature is also fixed, so to crank up heating power, supply temperatures need to be high. And with fossil fuels, it's also easy to get high supply temperatures, as we burn oil or gas at several hundreds degrees of Celsius. But does it make sense to do this? We want our houses to be at 20 degrees, to shower at 38 degrees and to cook our food at 100 degrees Celsius. This doesn't require to burn stuff at several hundred degrees, right? To process steel, okay. Special furnaces have combustion temperatures of 1000 to 2000 degrees Celsius, which are required to melt and process steel or other materials we need. But for our houses and many other processes, this is not needed. Nevertheless, because of the widespread cheap availability of fossil fuels, our whole heating system is based on high supply temperature. And as a result, also the distribution systems and the way we try to prevent losses of heat. This makes it difficult to simply replace fossil heat sources for renewable ones. Often the principle of exergy is used to quantify and understand why it's not smart to use highly valuable energy carriers like oil, hydrogen or electricity to produce lukewarm water for showering and heating of buildings. Exergy is a measure for the quality of energy, as it is defined by how much useful work it can be done with a given amount of energy carrier. Both energy and exergy are measured in joules. But unlike energy, exergy is destroyed when energy is used. Without going into the details of how exergy is calculated, the figures on the slide illustrate that using a fuel or an electric resistance heater have much higher energy efficiencies than exergy efficiency. Therefore, it's better to use high valuable exergetic energy carriers for the highest required quality. Following from what we learned in this video, we have two main things we need to change in existing buildings or processes, or do differently in new buildings and processes to facilitate the use of lower supply temperatures for heating. The first is to reduce peak heating demand. This seems like an open door, but many people, including professionals in the field, often forget. This is commonly done by insulating or other measures reducing heat losses. A major added benefit of doing this is that it will also reduce the total required heating demand. Second is to increase heat exchange surface area, for example within the walls and floors of buildings. This will help us to find sources of heat that fit the temperature level of the processes we need to heat or cool down. An additional benefit of this is that we use the building mass to create flexibility. The building mass won't change in temperature quickly. This also allows to play with when we supply heating, for example to further reduce peak demand. Also, this type of heat distribution is much more comfortable, as heat is released evenly distributed in a room rather than at one place at very high temperatures, being dependent on free convection by air to heat up the entire room. Please bear in mind that despite these efforts, you may still need conversion of temperature level and storage to be able to utilize local renewable sources of heat. That is why in the next 3 technical weeks are key in this MOOC. During the lectures in those weeks, you will learn which technologies can be used and how to mix and match them to design renewable heating and cooling systems for your project. Now, let's summarize our learnings. Fossil fuels created a lock-in for high supply temperature systems. As a result, we need to reduce peak demand by reducing heat losses and increase heat exchange surface area to ensure we can supply required capacities with lower temperatures. And last but not least, apart from the harmful greenhouse gas emissions, burning high exergy fuels to produce lukewarm water is a waste of exergy. Using low temperature heating is exergy efficient. Thank you for your attention.